Hello guys, today we're going to talk about pedigree. What's a pedigree? Pedigree is like a family tree. It can show information about an inherited trait passed across generations. It shows us ancestors and their offspring. In pedigrees there can be circles and squares. Circles represent females while squares manifest males. In pedigree, circles or squares can be shaded. If circle or square is shaded, it means that questions are directed to these ones. We can determine parents' possible traits. Due to autosomal dominance, autosomal recessive, X-linked dominant, X-linked recessive, Y-linked traits. We find all these by help of Punnett square. Well, as we have enough information about pedigree, let's solve problem. Imagine we have family like this. And now we are going to find possible genes, traits according to autosomal dominance, autosomal recessive, X-linked dominant, X-linked recessive, Y-linked traits. All of these traits belong to father and mother. Let's look at autosomal dominant. To have this result, our father should be heterozygous and the mother is homozygous recessive. The possible variations of their offspring are homozygous recessive and the heterozygous ones. If both of father and the daughter are heterozygous, mother and the son will be homozygous recessive. Well, to have this result, we need our father to be heterozygous and the mother is homozygous recessive. Next one will be autosomal recessive. For this, father should be homozygous recessive and the mother heterozygous. So as a result, daughter will be homozygous recessive and son will be heterozygous recessive. All of these same as previous one, just mother's and father's gene are changed. To find X-linked dominant, father's genes should be dominant and the mother's genes should be homozygous recessive. From these genotypes of daughter will be heterozygous 1 and the son's genotype is recessive 1. In the end, our father and daughter are dominants, while mother and son are recessives. The next one is X-linked recessive. Let's consider that our father is recessive 1 and the mother is heterozygous 1. In this case, daughter's genotype is recessive and the son's genotype will become dominant 1. Well, by this way we take our results. Y-linked trait cannot be here because to be the Y-linked trait it requires only all males to be shaded. In our situation it is not like that, so Y-linked trait has no probability at any way.